Okay, so I'm going to go ahead and get started right now. So first off, welcome everyone to our second day of our data science program for Tech Girls United. Just to let you guys know again, I'm going to be recording this session as well. So I just want to make sure everyone's aware of that. And we will be sending out the recording for yesterday and today, hopefully later today or tomorrow. We're just trying to clean that up and get rid of like the unnecessary sections in that recording so that's a lot more easier to navigate. And then we're also going to be uploading that to YouTube so that we can like share the link with all of you. A few more updates. So I know in the announcements channel yesterday I released our website. Our website is techgirlsunited.wixsite.com/tech, and we recently released it yesterday. So make sure to check it out. It will be being continually updated with a lot of useful information that we'll be having regarding our future events, because I'm sure you guys know that this is our first event and we're planning to have a lot more to come. So we'll be updating the events page with future events and then also more info and resources for girls in technology. Along with that, we have a newsletter that it would be great if you guys could subscribe to that, especially since you will be getting updates about our future events from that and you won't have to be constantly like checking our website. We also have our social media pages linked on the website below, so you can also follow us there for more updates. We definitely have a lot planned out even after this program so that learning doesn't stop with this. So make sure to check those out. Also, I've had a few questions regarding international students and how the active participation thing is going to work with that. And right now we're trying to kind of figure out what we're going to be doing with that. But we are going to try and figure something out such that it's not unfair to the people who are showing up in person. But we also do want to give them some kind of opportunity. So we will be contacting the international students based on that information. Let me see if there's anything else. I think oh yeah, and then we'll be sending out the slides and the demo code that we'll be using after the session, like pretty soon, maybe like within the hour after, so you can reference that as well afterwards. And right now I'm done talking, so I'll pass it on to Trisha, who will be taking over and showing us the Numpy curriculum for today. And just to clarify, so yesterday we went over Python, which is a really common language in data science. And in the future days, we're going to be going over the different libraries that we can use with Python to perform stuff like data analytics and different skills that we'll need for data science. So, Trisha, are you ready?
Yeah, I'm ready.
Okay, so I'll give you screen sharing capabilities. So can you try screen sharing right now?
Can you see my screen?
Yeah, we can see your screen. That's perfect.
Okay, cool. Okay, yeah, welcome everyone. I guess I'll just give a little introduction. So I'm Trisha. I'm currently a rising junior in high school and I'm part of the curriculum development team. And today we're going to be going over the Numpy Python library. So what is Numpy? So Numpy stands for Numerical Python. It is a Python library for working with arrays. It analyzes data more efficiently than when using Python lists. So basically the data is stored in one continuous place in memory, unlike lists. So the process can access and manipulate them really efficiently. And this behavior is called locality of reference. It adds support for things like multidimensional arrays and matrix structures, which we'll get into later. And it's mainly used for mathematical functions. The array object is called ND array, which we'll also get into later. So now I'll introduce multidimensional arrays. So a one-dimensional array has one tuple. A two-dimensional array, also known as a matrix, has two tuples, and a three-dimensional array has three tuples, and so on. So this is a pretty basic concept, but it's used a lot in Numpy. So now we can go over how to create an array. I put examples on the slides that you can refer to later, but I'm going to be like showing them and like writing them out. Can you see my screen?
We can see your screen.
Okay, cool. So let's start with creating a one-dimensional array. So first you need to import Numpy as NP. So since they're imported under the name NP, you can use NP instead of Numpy. So you can create a Numpy ND array object using the array function. So let's just do my array equals np.array, the array function, and then inside that we'll have a list of like numbers. And then let's just print the array function, or sorry, the array. Okay, so as you can see, you get the list here, which is basically what you wrote out inside the array function, and that's just how to create like a one-dimensional array. Does anyone have any questions on that? Okay, yeah, cool. It's pretty simple. Once you get used to like the syntax and everything, it's not that hard to like remember.
Yeah, and if you guys do come up with questions, you can stick them in the chat. I'm sure Trisha will also go over like any questions you have at the end as well.
Yeah, for sure. So now we'll move on to two-dimensional arrays. Also like a quick tip in Python is like when you want to comment out like large blocks of code or something, instead of using like a hashtag, which I think we went over yesterday, Shalini mentioned, you can also use like 3 like quotation marks, and you can like comment out like more than 1 line of code. So that's just like the Python tip. So now we'll move on to two-dimensional arrays. So let me go back to the slides. Okay, so this is an example of a 2D array, and 2D arrays are also known as matrices. So let me just show you how to create one. So you're going to use the same import statement. So import numpy as np. Then you're going to create an array, but instead of creating an array with only 1 dimension, you're actually going to create an array with 2 dimensions. So basically inside the list, which uses the square brackets, you're going to have 2 other lists. So that's why it's like 2 dimensions inside that list. And then that's basically your 2-dimensional array. So now we're just going to go ahead and print this. So as you can see, you have 2 dimensions now. It's not just one set of square brackets. You have 2 sets of square brackets, so it's like a 2-dimensional array now. And now we'll go into higher dimensional arrays. So higher dimensional arrays are usually thought of as 2+ dimensions. So let me just show you how to create them. So you're just going to say import numpy as np. Then you're going to create an array. And then inside the square brackets, you can just write out any sort of like list that you want. And then to define the number of dimensions, you're just going to say ndim. So that's like number of dimensions. And we're just going to use 5. And then if you print this, oh, I made a mistake. Let's see. Ndim is not, oh, okay. Sorry. It's not ndim, it's ndmin. So yeah, so as you can see, you have a list and it's inside not just like 2 square brackets, but it has 5 dimensions. And then also if you want to like find out the number of dimensions your list has, you can just say like print number of dimensions, comma, and then like the array name dot ndim. So ndim is basically to find out the number of dimensions, and then ndmin is to like assign the number of dimensions. So when we print this, we can see that it says number of dimensions is 5, which is what we assigned it to. So yeah, now we'll move on to the next example. So now we're going to cover the basics of arrays. So we'll start with array indexing. So array indexing is the same thing as accessing elements in an array. You can refer to its index number, which starts with 0, and you would do the same thing as you would accessing lists in Python. So you would do the array name and then the index number inside square brackets. So let me show an example. So import Numpy as np. And then we're going to do my array equals np.array, and then the list. So we want to access like the first number in the list, and the index starts with 0. So can everyone like put in the comments or like guess what number we'd want to put in the like square brackets to access the first element? Like just a reminder, the index starts with 0 and we want to access like the first element. So what like number would we want to put? Yeah, 0. I think everyone answered that, right? So we want to print my array, and then inside the square brackets, we're just going to put 0. And then, yeah, so we get 1, which is the first element of the list. So yeah, that's how to do array indexing for one-dimensional lists. So now we're going to move on to array indexing with two-dimensional lists. So you would use the first number in the square brackets for that I mentioned, and you would use the second number for the index of the element. So it's basically the same thing, except this time you have 2 numbers inside the square brackets. So import numpy as np, and then you could do my array equals np.array, basically the same thing. Sorry if you can like hear my dog barking. Okay, then you would just do like a print statement, and then we want to print oh sorry, this should be a two-dimensional array, so it's inside 2 sets of square brackets. Okay, so in this two-dimensional array, we want to print the second element on the first dimension. So this is the first dimension, this is the second one, and we want to access the second element on this. So we would basically do like second element on first dimension. To do that, we would just do my array, and then inside this we would have 2 numbers, which is 0 for the first dimension, and then we would have 1 for the second element. So when we print this, we have, oh, something went wrong. Oh, sorry. Yeah, so we have the second element on the first dimension, which is 2. It's not a colon. You would use a comma to separate the 2 numbers inside the square brackets. So does anyone have any questions so far on this? I haven't been checking the chat, but let's see. Okay, we'll just keep going. So let's move on to the next example. So now we'll move on to array slicing. So some of these things might seem pretty familiar if you've sort of worked with Python lists before. So your slicing is basically taking elements of one given index to another given index. So it can be start, colon, end, or start, end, and step, and I'll show that in the example. Okay, so we're gonna start import numpy as np, like usual. And then, so we want to create a one-dimensional array. So we're just gonna say my array equals np.array, and then inside the array function, let me just do like 1, 2, 3, 4. We'll put 6 numbers in. Okay. And then so now I only want to print the numbers from like 2 to 5. So what index numbers would I use to locate these elements if I want to print the numbers from like 2 to 5? Just a reminder, like the index starts with 0. So can everyone like put in the chat what numbers I'd want to access these elements? Let's see. Okay, so to access these elements, I would use 1 and 5. This is because the 1 starts with 0, then it's 1, 2, 3, 4. Okay, hang on, let me just show this. My array 0 colon 5. Sorry, 1 colon 5. Yeah, so this would show the numbers from 2 to 5 because it's basically slicing or taking out these given numbers and creating a new sort of given index for them. Okay. So yeah, that's basically it for this example. And then now we'll move on to array shape. So there's an attribute called shape that returns a tuple with each index having the number of corresponding elements. Basically, it returns 2 values, the first one being the number of dimensions, and then the second one being the number of elements. So as you can see in this like sort of diagram, it kind of shows like a little example of this, but I'll just show another one with a 2-dimensional array. So we're going to start import numpy as np. And then now we're going to create a 2-dimensional array. So just like a little like reminder, you don't have to use like different numbers for each of like the elements in the array. I'm just like showing that for like the example purposes. So now let's print the shape. So to use the shape method, you would say my array dot shape. So when we run this, we can see that it's 2, 3. So again, the first number basically stands for the number of dimensions. So as you can see in this array, there's only 2 dimensions. So that would be 2. And then the second number stands for the number of elements per dimension. So this is 3 elements, and then this also has 3 elements. So it would be 2, 3. And then, like, for example, if this was like 7 or something, and it had like a different number of elements. Okay, anyway, it shows like an error, but if like the one dimension had like a different number of like elements than another dimension, it would basically just not have another number. I would show that in a like 3-dimensional array, but like I think that would be a little bit confusing. So we'll just like keep it at this. Okay, so now I'll introduce how to join arrays. So basically, a lot of Numpy is basically manipulating arrays and like learning all these like different methods and everything, because there's actually like a lot more that you can do with them, and I'm just basically like showing the basics. So how to join arrays. So joining means putting contents of two or more arrays in a single array. So we pass a sequence of arrays that we want to join to the concatenate function along with the access, and then if the access is not explicitly passed, it's taken as 0. So we'll go over all of this in an example. So basically, let's just do import numpy as np, and then let's create two arrays. Dot array, and then we just want to create one-dimensional arrays. Okay, so if we want to join these two arrays, one thing that we can use is the concatenate function, like I mentioned before. So we would just say array equals np dot concatenate, and then we would just put inside the function array1 comma array2. And then if we print this array that we use to join these two arrays, we would get these two arrays joined. So this is 1, 2, 3, 4, 5, 6, and then the joined array is like all of them combined. So yeah, that's how to join the arrays. And so now I'll go over how to concatenate two-dimensional arrays, because I know like it can be a little bit confusing at first. One-dimensional arrays are usually like easier to understand, so I think it's important to understand how to like do that too. And then so first import numpy as np, and then we'll just like basically copy the same thing, except we'll add 2 dimensions to each of these. Okay. Did I make a mistake? Oh yeah, okay. Yeah, so we have two-dimensional arrays. So then we're also going to use the concatenate function again. So np dot concatenate, and then inside this we're just going to do array1 comma array2. And then also over here we want to define the axis. So for two-dimensional arrays, there's actually only one axis, so the only value we can use for this is 1. But for arrays with more than one dimension, you want to make sure that you're defining which axis you want it to be on. So basically for that, it's just showing where you want to concatenate the functions. So by saying it along axis 1 for two-dimensional arrays, you would basically just be concatenated or join it along the rows. So this might be a little bit confusing, but I'll show it in the example. So yeah. So as you can see here, it's joining it along the rows instead of just like joining each of these dimensions separately. So I'll actually show that without the axis, without defining the axis. It would just have these each be separate, but once you define the axis, you can actually join it along the rows. And like I said, like two-dimensional arrays only have one axis. So if you use a number that's like above 1, then you get like an error. So yeah, be sure to know how many axes are in the arrays. Okay. So now I'll go over array iterating. So iterating means going through elements one by one. As we do with multidimensional arrays in Numpy, we can do this with the basic for loop. So we learned the for loop yesterday. And if we iterate on a 1D array, it will go through each element one by one. So I'll go ahead and show this too. There's like things in the chat. Oh, okay. Okay. So again, we're going to start with import numpy as np. And we're just going to create a simple 1D array. So when I'm like typing, you can see that there's like a lot of like lines under these things, and you're probably like, okay, what is that? So basically, when I type just this statement and I'm not using np, it's like sort of an error because you actually have to use it when you import it. But yeah, if you're just like wondering like why there's like lines under this and everything, and also like as you can see, like this is like invalid syntax, it's not assigned to anything. So yeah. Oh no. Okay, I'm not sure what happened. We're having some technical difficulties like yesterday. Okay, so basically what I was gonna show is I'm creating a one-dimensional array, and then I'm also creating a for loop. So as you learned yesterday, I would write something like for x in my array. So for x in each value of the array, I would print that value. And then it would basically just go through each value in the list and print it like on a separate line. So if this works, I can show you, okay, I can show you the example. So my array equals np.array. Just create a simple like one-dimensional array. And then we can go ahead and do for x in my array. So remember to use the for loop syntax. So you have the for, and then you have like a variable, and then you have in something, and then you use your colon, and it's indented on the next line. And then I'm just going to say print x. So print each value. When I run this, you can see that it prints each value in the list. So that's basically what iteration is, and it's pretty important to Numpy. So it's important that you understand like the basics of it. And then, I mean, I guess I can also go over iterating 2Ds, a 2D array. So basically for that, it's like the same thing. So you have a 2D array, and then you just say for x in array, print this. And there's another way to print each element. I think it's for y in x, and we do for x in array. I actually don't know if I'm doing this right. Okay. Yeah, let me not show that example. Let's just go back to iterating. Okay. Yeah, so does anyone have any questions on iterating a one-dimensional array? Yeah, so I think pretty much like other than the syntax, it's not really too complicated to, oh, someone asked a question. Will Python catch it as an error if you have imported it but don't actually use it then? So if we like try this, like let's just say like print, okay. We're just gonna say something random, like we're just gonna say like x5 and then like print x. So like as you can see, it's still like prints it and everything. You're just not using like Numpy, and you're not using like this thing that you imported. So it's not, it won't like catch it as an error, and it won't like make your program stop running or anything, but it's just like good practice to like not import stuff that you're not gonna use at all. So yeah. Let's see if there's any more questions. Okay.
Yeah, the reasoning behind that is just that it's really unnecessary to import a library and then just not use it anywhere in your code.
Yeah. And then someone asks, why do you have to import Numpy every time? So Numpy is a Python library, and in order to use it in your code and use all the functions and methods that are available in Numpy, you have to import it. So that's why we always have to write import Numpy as NP. And basically that statement, we can basically just use NP instead of Numpy. So if we just said like import Numpy and then we like created an array, and then we just said like numpy dot array, and then we made an array. It's like the same thing. Like you can also use this if you like don't want to use np. Like it works the same exact way. So yeah, you can also use this. Just using like np just like makes it shorter, and then you can just use np instead of numpy. But yeah, and then let's
Also,
see.
I'm not sure if this is what you were actually asking, but you might have been, I'm not sure if you were referring to the fact that I know she wrote like import NumPy each time she had an example. You don't technically have to do that if you just leave it at the top of your code. So you would just like define it once at the like top, and then you can continue using like NP throughout your code. You don't have to like do it each time. It's just each time she was commenting out that statement, that's why she continued doing it for each example.
Yeah. Okay. Let me just write this example that I wrote here before. Okay, sorry. Just give me a second. Okay, yeah. So now we'll move on to the next example. Oh wait, no. So now I'll just basically go over like a brief, like very brief introduction of like the other functions and methods. So there's reshape, copy, view, array split, where for searching like if something is in an array, sort, filtering an array, and random, or rand, which is basically for random. And there's a lot of other like functions and methods that you can like learn about for NumPy. I keep saying NumPy. It's NumPy. NumPy. So there's a link here on the bottom if you want to check that out and like learn more about it. For my advice, like I recommend just like trying out a project and like just like opening like a GitHub repo or something and just like trying out a bunch of different things. So okay, so now we're gonna cover universal functions. So universal functions are known as ufuncs. So ufuncs stands for universal functions, and they are NumPy functions that operate on the ND array object. So ufuncs are used to implement vectorization in NumPy, which basically covers iterative statements into a vector-based operation called vectorization. That sounds really complicated, but I'll go over this in the example. Okay. So we're gonna import NumPy. Sorry. So let's say we want to add the corresponding elements of a list together, but in a new list. So with, for example, with like ufuncs, we can use the Python built-in methods instead of iterating both lists and adding like the sum of both lists. So instead of doing something like this and like iterating each list, we can use the built-in methods. So let's say we have like a list, which is like we have a list for X and then Y. Okay. And then we have a Z list, but it's an empty list, like there's nothing inside. And then to do this, we would use a for loop. So for I, J in zip, X comma Y, and then the colon. and then we would do z.append. So append is basically when you want to join two lists together, so you would just use append. It's like used in Python, if you're like familiar with that. But I can like explain it more if you like don't understand that or have any questions. So basically what we're doing in this like text is we're taking each value from the X list and we're taking each value from the Y list, and then we're adding the first elements together. So zip X comma Y, and then we're appending these elements into the Z list. So as you can see, when we print the Z list, we get 5, 7, 9, 11, which is 1 plus 4, and then 2 plus 5, and then 3 plus 6, and then like so on. So yeah, this code might look a little bit complicated at first, but with practice, you can like learn a lot more about it, and like you can learn how to like use these a lot more comfortably. And yeah, does anyone have any other questions or like questions relating to this? As you can see, like in this code, I actually didn't use Numpy. So even if like I didn't have this here, it would still work. But yeah.
Could you go over what the zip is doing?
Yeah, so the zip function returns a zip object, so which is an iterator of tuples where the first item in each past iterator is paired together. So basically we have each item, so for I in each item in the Z list, and then J for each item in the Y list, it's basically converting those elements to an I and a J. Okay, I'm sorry. This is like really complicated. So basically, for each element in the X list, it's assigned to the variable I, and then for each item in the Y list, it's assigned to variable J, and then this loop is running as many times as there are elements in both of these lists, and then it's adding the I and the J element. So basically for 1, it would just be 1 plus 4, and then it's appending that value to this, and then it keeps going, it goes back around, and then it does 2 plus 5, and then it's appending that value, and then it keeps going like that. It's kind of complicated to explain. I don't know if like I'm explaining it in a way that like makes sense, but yeah.
Why don't you try? Oh wait, you can go ahead if you had a question. Okay, Trisha, why don't you try, instead of just printing out like the dot append, try printing out like the tuple ij, just so like it's more clear, like how you can see it like iterating and how you can see them kind of like pairing up.
Do you mean like this, or taking out this? Okay, yeah. So basically, this is like how it iterates. So this is the X value, right? And then this is the Y value. And then this is how it's going through the list. So it's starting with one X value, one Y value, and then the next one, the next one. And then so it's adding these two together. So the thing that I took out was the I plus the J. So instead of like adding the values, it's just printing each of the values. So if I would do like print I plus J. Yeah. If I put it back to like how it originally was, you can see that like all of the values that were listed, it added the two values together. So it added the I and the J pairs, and then it went back to the start of the for loop, and it executed for the next pair of values, and then it went back, and then it executed until there's no more elements left in both of the lists. Does that make more sense? Okay. does anyone have any other questions on like any of the examples that I covered so far? Okay. Yeah, so that's basically it. I do have some other examples in the end, which are dealing with like more higher dimensions of like some of the other examples that I went over. So I could go over those too, if you want.
Yeah, you can go over those. How long do you think they will take?
Okay, yeah, I think probably like less than 5 minutes explaining some of these. I think they're pretty simple if you understand like the other concepts. So this is using the, let me go back to the slide. Cool. Okay, yeah, so this is using the array indexing, and it's basically also taking like a step. It's a more complicated like example. So it's taking the first dimension, which is this one, and then, wait, okay, yeah, it's taking the first dimension, which is this one, and then it's taking the second sort of like block in that dimension, and then it's taking the third value, because number 2, since it starts with 0, it's 1, 0, 1, 2, so that would be the third value, so then it's taking number 6. This is a one, I think, yeah, this is a 3-dimensional array, and then so if you want to like learn how to sort of like index or sort of slice these, you can learn how to like write them out, which is, they're like slightly more complicated than 2-dimensional arrays, but it's not that hard to like figure out. And then does anyone have any questions on the example that like I just showed? Why did you combine the first and the second set? In which example are you referring to?
I think she's talking about the last one.
This one?
Yeah.
Okay. Why did you combine the first and the second? So do you mean like the X and the Y list? So basically this was sort of, I was trying to show like how universal functions like work in Numpy. So in this, instead of like iterating both lists out, so let me see if I can actually do that. So for example, if we did like something like this for like I and X, and then print I, wait, yeah, and then for J and Y, print J, and then we did something like Z dot append I plus, okay, wait, let me just lay this out for now. So again, we would just get like the separate lists appended out, and using like the universal function method, we were able to sort of combine it and do it together. So okay. Append I plus J, and then we would just be able to print C. Instead of like iterating these like separately, like instead of iterating just the X list and just the Y, we were able to do it in pairs and then append the sum of the pairs to the Z list using the zip function and the append. So yeah. I hope that answered your question. Oh, why did you combine the first and the second set in the new example? So this one, or should I go this one? Can you go to the code with a 3-dimensional array you were just on? Okay, yeah. Yeah, this is a 3-dimensional array. Do you have any other questions on this one? Do you mean like why I combined like these sets? Okay, yeah, okay. So basically for a 1-dimensional array, let me just like write an example. So you have only one pair of like square brackets. So you have like 1, 2, 3, 4. For a 2-dimensional array, you have actually 3. So let me show you an example. So you have like 1, 2, and then you have 3, 4. So if I went back to like this, you can see that it has like 2 dimensions because one of inside like the whole list, you have this list and then you have this list. So that's 2 tuples, like I said in the example or in the diagram. This is also known as a matrix, by the way. And then to make a 3-dimensional array, you would need basically 3 of these. So just like it was shown in the example, instead of how you would in a 2-dimensional array, you would have like 3 sets of tuples. I don't know if I'm like explaining this great. So I'm basically just like rewriting the same thing that's like on top. We have like 10, 11, 12. So there's 2 here. So there's one pair of brackets that's around the whole thing. There's one pair that's around here. There's one pair that's around here, and then there's another that's around here, and then inside there's 2 separate pairs in each of these. So this is known as 3 dimensions. Okay, cool. Yeah, so I think just like I said, like experimenting with these, like there's some like really weird stuff that you can like do with some of these functions. Like I think even in like the example that I showed before with like the ndim example, like if I assign this to like 20 or something and like I printed it out, it would just look like really crazy, but it still like works. So there's like a lot that you can do with like the features on like Numpy, and there's like a lot of projects that you can also like try out. And then so I did attach some resources on the slides that you can like refer to later. And yeah, does anyone have any other questions on anything that we covered? If not, I can go over the 2D iterating example. Okay, yeah, I think I actually showed this, but yeah, this is basically just iterating each each section of the 2D array. So for X in the array, it's printing X. And then, yeah. Yeah, I don't think I went over this. Okay, so for slicing higher dimensional arrays, like 2+ dimensions, you would have 2 sort of like pairs of numbers in the like brackets when you're slicing it. So for example, for this one, if I wanted to slice the second part of the 2-dimensional array, and I wanted to only slice the numbers from 7 to 10, I would use 1 because this would be the index was stored at 0, so this would be 0, and then this would be 1, so I would define it as 1, and then I would define the numbers from the index numbers from 1 to 4, so that since it's 0, it would be 1, 2, 3, 4, and then it would just slice these. Oh, sorry, it would just slice these. It's 1 to 4, but it stops at 4, so it would be 1 to 3, basically. If I wanted to include 10, I could do like that. And then it would basically just, yeah, 7, 8, 9, 10. And then okay, yeah, let me not get into that. So yeah, does anyone have any other questions? It can be on like trying things out on like other dimensions, like how to sort of like slice a like 3-dimensional array. I think I can try that. Try to make this like a 3-dimensional array. Or we can try to slice this one. So yeah. So yeah, there's like a lot of different things that you can like try out. This doesn't really have any like specific meaning, but yeah, you can basically test it out. And I'd say like, I think I'm pretty new to like Numpy, and like the thing that like got me pretty familiar with it was just like trying out different things and like seeing if like I got an error on something and like I wasn't allowed to do something. For the replit where you change the dimensions to 20, a bunch of brackets around the array. So are the extra brackets empty arrays? No. Okay, so yeah, so in this example, what this would be is just 1, 2, 3, 4, but it would be in each like section of the array. So you see how like this is like a 2-dimensional array, right? There would be like 20 of these. And in each section, there would be like 1, 2, 3, 4. Does that make sense? So you don't have like empty lists inside. They all have like the same like bunch of elements. What is NumPy used for? So, okay, I can go back to like the introduction. So NumPy is basically a Python library for working with arrays, and it's used for like analyzing data. There's a lot of other functions on NumPy that really help with like analyzing like large sets of numbers and data. So there's a lot of other functions that you can check out, a lot of other ufuncs. Yeah, there's like a link here if you want to check that out. And then, does anything change with the code if you have different data types in the list? So why don't we try that out? That's a good question. Yeah, so like I said, like you don't have to use like the same numbers, but yeah. Okay. Hello world. Okay. So yeah, as you can see, nothing changes. It's just the same thing inside. So it's not just for necessarily organizing numbers, even though it's like really helpful for that. Like that's basically like, there's like the zip function and everything, and like the append, which helps like a lot with numbers, but you don't necessarily have to use it for like analyzing that. And you can also use different things like strings, or I could even do like a Boolean, like true. Okay, wait, no, I can't do that. If I did like x equals true. Okay, never mind, just scratch that. Let me not just show that example. Okay. And
Just one thing to note is that with Python, you can use different data types in like lists or arrays, or basically I think anything in Python. That's just one of the cool things about Python as a language in general. So she could have like a number and a word and like a string. It doesn't have to be like 2 strings or 2 integers or something like that.
yeah. So like Megan was saying, I could do like 2 and then world, and then it would also work. Oh, good. Hang on. Yeah. Does anyone have any other questions? So yeah, all these examples will be like available to you. I think we'll post like the Replit link on Discord. So you can like try out these examples, or you can like go to the links and like the resources that I posted. You can even like just search up like Numpy Python library like projects or something. Numpy kind of reminds me about the list. Are they related in any sort of way? So yeah, so we've been like basically dealing with lists. So we have an array, and then inside we use the square brackets, which is a list. So yeah, and then we also use things like append, which is things that we use with like lists in Python. So yeah, they are related.
Yeah, they're really similar. It's just arrays give you more flexibility since you can work with like more dimensions. So you have a lot more things you can do with the data. So Trisha, if you're done, we can move on. So did you have anything else you wanted to go over?
I think that was basically it, yeah.
Okay, that's cool. So yeah, you can stop because I'll be screen sharing in a little bit.
Okay, sure.
Okay, so first off, thank you, Shalini, for answering like a ton of the questions in the chat as well. It was really helpful to have you over there. And the thing I wanted to go over right now was just that we're going to be having a final project for all participants that they can like work on and basically apply what you guys are learning. So I'll just be going over that really quick. Just give me a second to share my screen. Okay, wait, I just need to open it up. Okay, so this is, these are the guidelines we have for the final project. We will be sending these out in the Discord server. And essentially, we've just provided you with 3 different data sets. You can choose from the 3 to determine which one you want to be using for this project. All 3 data sets are linked over here. And you'll essentially be using the different skills you've learned, like Python, Numpy. Tomorrow you'll be learning about pandas, and we'll also be learning how to use matplotlib. And you can basically apply that to these 3 data sets. Along with this, when you're looking at a data set, you're going to have to kind of consider what you want to do with the data. That's the first step when you're starting to, do any kind of data science project. So here we have a few questions to kind of get you started, but this is definitely something you want to start thinking about today. And then tomorrow, like I said, we'll be going over pandas with Shalini, and essentially pandas will let you visualize the data a lot more clearer. That will really help you out a lot with analyzing this stuff. So definitely it might be helpful to start maybe working with the data after we learn pandas, but you can also start taking a look now and using these data sets to try and understand what the data is about and what you can do with it. So I'll stop sharing, and like I mentioned, I will be including this on the Discord server, and everything that Trisha talked about and showed you guys today will also be in there. I'll be sending out the attendance form right now as well. So if you guys have any other questions, you can also just speak up right now, or you can ask us in the mentor help channel, or I've seen people using the general channel as well. So either of those work, and we will be answering any questions you have. You guys are free to leave, unless you have any other questions you want to ask us.